Well, good morning, everybody, and welcome to the Animal Welfare Plenary, and it's great to see so many of you still here on a Saturday morning. My name is Dr. Holly Farmer. I work at Paignton Zoo, and I'm the chair of the EAZA Animal Welfare Working Group. And I'd like to introduce our session, which is all about the use of technology to help assess and improve animal welfare in our EAZA collections. So just a quick outline of the plenary. First of all, I'll give a short introduction about some technology, particularly aspects that won't be covered by our keynote speakers. Then we'll be hearing from Professor Robert Young about the use of sound to measure behaviour and welfare. Then we have a GPS demo by our co-vice chairs of the group, Dr. Lisa Holmes and Graeme Dick. And then Dr. Gerardo Garcia will be talking about using thermal imaging for animal welfare management. And then I'll give a quick update on the working group and some exciting new things we're doing in the future. So first of all, I want to explain a bit about why we chose this topic for our plenary. It's really exciting to be given the opportunity to do a plenary at the EAZA annual conference, so we had to really think hard about what we wanted to talk to you about. So when thinking about assessing animal welfare in our collections, the first thing you might think of is that we have a massive variation within our collections of the types of species and the number of animals we might house. So a little example at the bottom of the screen. So at Paignton Zoo, where I work, we have about 270 different species and around 2,500 animals in our collection. However, if you go to Chester Zoo, you'll see just over 500 species and about almost 25,000 different animals in their collection. So you can imagine assessing the welfare at Paignton might be slightly easier or take a little less time, depending on how thorough you are, than Chester Zoo. And this is seen, obviously, across the board. However, sometimes we have quite small sample sizes, so some collections might have only one or a small group of one particular species. And we do have limited group replicates, which means we don't have lots of the same species in lots of zoos, which means we can't make really good generalizations of what's going on. We obviously have very big differences within our husbandry, whether that's just simply how the animals are managed, it might be their nutrition, their lighting they're given, really different aspects that really might influence their welfare, so it's very difficult to compare between our collections. We often have limited access to our animals as well. We might be very hands-free, we might have them in a large safari park, they might be aquatic, and so it might be very difficult to actually even see the animals clearly on a day-to-day basis to be able to assess their welfare. And also we know that a lot of species that we manage are part of captive breeding programs, and so for one collection to do a long-term study on an individual or a group of animals is a bit limited because obviously due to animal breeding transfers. We also have a big issue with funding, and I'm a zoo-based researcher, but I also manage a stud book. But working in a zoo, we know that we're not accessible to as much funding as maybe some of the academic collections might be, and having charitable status can really influence that. However, we can collaborate with academic institutions, and they often have a larger pot of money than we might have potentially for doing this kind of work. We know that sample analysis is quite expensive, and throughout our talks we'll be talking about potentially doing fecal or blood or hormone samples, and we know that's quite pricey, particularly if you've got such a large collection as some of our zoos do. And something we're obviously going to talk about today is equipment, and you might think to assess welfare you need lots of different equipment, and that again might be quite expensive, and then you might need to employ staff to actually conduct this work. And also, if you find that you can make a welfare improvement, often it can cost money to make these husbandry changes, and so that will obviously incur a cost. But for a lot of species, we just don't really know enough about them to be able to accurately assess their welfare. So it might be that they're data deficient in the wild, and so if we feel like we need to compare captive and wild behaviour, it might be very difficult to do that if we just don't know enough about them in situ. And often we don't have a lot of reference values. For those of you that use ZIMS, you might find that it's really useful in the medical side of things, and particularly with weights for global reference values is really helpful. But for species that we don't do a lot of research on or know very much about, we won't have this information to use as a comparison. And as I've mentioned, often we just don't know what typical behaviour is or what a normal parameter is. And often some species don't have any external signs of either poor or positive welfare or even stress indicators, so it's very difficult for us to even assess what's going on with them. And often a lot of collections don't have any access to staff or students to even conduct the welfare assessments. Obviously, ideally our keepers would be able to do this, but we know that their time is very limited and they're obviously very busy on a day-to-day basis. We're very lucky with a lot of collections that we do have very strong research centres, but if you don't, it's very difficult. There might be a lack of expertise in a collection. People have a lack of time simply to conduct any of these audits or assessments of welfare. And it's a bit of a change in the mindset as well in terms of how much time we should spend actually assessing the welfare of individuals and how often we need to do that. And this fear of technology. We know we live in a very technological age. We've all got iPhones and apps and iPads, and we use a lot of exciting technology on a day-to-day basis. But when you think about applying it sometimes in your work, it might be a bit nerve-wracking. And so hopefully that's something we'll really put your mind at ease at this morning. So when I'm talking about assessing animal welfare, I'm mainly talking about non-invasive tracking of behaviour and physiological welfare, because in a couple of the talks we've already heard at EAZA, we know that a lot of zoos are very limited by legislation. We are particularly in the UK to actually do any invasive work in terms of assessing the welfare of our animals. So being able to do it non-invasive or behavioural welfare is much more beneficial for us. And there are some really relevant publications looking at that and looking at globally. So what can you do? What kind of technology can you use to help assess the welfare of your animals in your collections? Well, there are a range of simple apps that you can use to basically collect behavioural data. This can be conducted by students or keepers or managers, however often you like, and there's lots of accessible apps. Some are free, some have a small cost, but we know that they're quite good to actually just be able to monitor what's going on. And in the last few weeks, we know that Species 360 have brought out a new module in ZIMS which will allow you to start monitoring the welfare of your animals in your collection. And that's a really exciting move forward, and hopefully it will keep developing over the next few months. However, you can use much more exciting and quite innovative aspects of technology to measure your welfare. So what you can use are things like accelerometers, which basically look at the velocity or the movement of animals to be able to map activity patterns. And what I've done throughout my talk is just given a couple of examples which are published, so the references are at the end of the screen, just to give you an idea of how they might be applied in zoos. So we look at giraffe. We know that giraffes sleep in 3 different types of positions. That's standing up, a recumbent sleep, and a real deep sleep where they've got their heads rested on their backs. And so by using an accelerometer, attaching a data logger to the leg of these giraffes at Brookfield Zoo in the US, it allowed the keepers and the managers to look at their general activity, but also their positioning, which allowed them to look at what position they were sleeping in, which is obviously great because they do this at night. They don't sleep for much of the night, only for 2 or 3 hours, but it's something we don't easily see. So they attached these data loggers to their legs, and they looked at activity levels and also did fecal sampling as well throughout the summer and the winter, because they wanted to make sure that throughout the year they were really optimizing the welfare for this species. And they found that glucocorticoids, a stress hormone or a hormone linked to stress and anxiety in species, was much higher in the winter months, and that the giraffe performed more active foraging rather than inactive foraging in the winter months as well. So this allowed the keepers and the managers to really think about how they were managing these animals and what kind of nutritional provision, thinking about their social grouping, and particularly the enclosure they were providing them within the winter and summer months, and making sure that they were giving them the optimum environment to live in. A nice study by San Diego Zoo on koalas also looked at activity levels with accelerometers and again did some hormone analysis. And they wanted to look at estrous cycles in their female koala bears. And they found that there was an increased level of activity which was correlated to a bellowing behaviour, which is kind of a behaviour that's related to the reproductive cycle. However, they didn't really find any other correlations between activity and hormone levels, because we know they're induced ovulators, and this is a group of females, so they knew that really they needed to have a male there to be able to look at it in more detail. But it was a really good baseline and a really good study to show you how you can look at different aspects of behaviour and physiology as well to assess their welfare. Now, you may think quite commonly, looking at how animals might use their enclosure and that activity, you could use global positioning systems or GPSs. And a really good example of this is at Disney's Animal Kingdom, where they looked at walking rates in captive African elephants because they wanted to make sure that they could try and mimic as much as they can a more naturalistic environment. So they had collar-mounted GPS units and also looked at environmental data loggers to look at what was really going on in their natural environment in the zoo. And they found that the travel, or the distance travelled by the animals in captivity was actually quite comparable to their wild counterparts, which is quite surprising, when it obviously will depend on the size of your enclosure. There was also a significant relationship between the amount they were walking and the temperature of the environment. So again, that can really influence management in terms of how you might heat an enclosure. And they also found that groups that were living in quite complex social systems and larger enclosure had much higher walking rates. So then maybe that would think about how they might manipulate the social systems, and again, thinking about how they could better manage their environment. And GPS is something we're going to be talking a little bit later on, so hence the only one slide on it, but my co-chairs will be talking about that. And so looking at this general activity, well, you can look at just general behaviour and you can look at activity and how they use their enclosure, but there's lots more aspects we can look at. And this is a really lovely piece of work on hunting dogs done by London Zoo ZSL and the University of College London in the UK. And what they did was they were looking at wild packs of hunting dogs, and they used something called a daily diary collar, which is basically this GPS unit, accelerometer, and a radio tracker, which had a really high frequency, so could really pinpoint what was going on with the animals in the wild. And they could really pinpoint key events, which was very useful. They could look at activity levels, and they could identify individuals and look at pack dynamics. Now, that's really interesting in the wild, but obviously we want to try and adapt some of our findings into the captive environment. So what London did was they did a wonderful training project, and they trained their captive animals to be allowed to attach these radio collars when they were actually in the zoo. So they had a wonderful training program where they actually got the animals to hold their heads in the right place, and they could attach these training collars and see how long they could keep them on for, kind of like a bit of a model for the wild. And it was really beneficial because London now can track their pack. They know the dynamics of their group. They can look at key events like late opening hours or enrichments, that kind of thing. They can really track what's going on in their environment and look at how they're using it, which can be really beneficial for additional welfare assessment tool. Now, there are some additional methods, obviously, I can talk about, but these will be covered by the keynote, so I don't want to take anyone's thunder. But obviously, bioacoustics are really important, and that's what Professor Robert Young will be talking about. But don't just think of bioacoustics as recording what animals do. I have to always get a howler monkey in my talks. That was what I originally did a lot of work on, and I spent a lot of time doing what this student did here, standing at enclosures, waiting for them to howl, which I can tell you now they don't do very much. You know, it's not just the fact that do they howl or not, or do they make a sound or not as a welfare indice. There's lots of other aspects that Robert Young will be talking about, and it's really exciting. And obviously using things like thermal imaging, and this is what Gerardo will be talking about. So whether it's mapping the Komodo enclosure at Paignton Zoo, potentially looking at not just external temperature, but also internal temperature of animals as well. So carapaces of spur-thighed tortoises like you have here, not just looking at the outside temperature, really making sure that our lighting and our heating systems are really beneficial for the animal internally as well. And obviously we've got health parameters that we can look at, and I know what we talked about a little bit later, but we know that vets often use thermal imaging to look at maybe areas of inflammation or disease or infection, and it's a really good tool for them to use as well. And keeping on the theme of looking at sort of health and welfare, there's some great work done by the Great Ape Heart Project, which we know that a lot of EAZA zoos are contributing to, where they basically use technology to try and look at heart health in our captive and in wild apes as well. So they can take blood pressure readings by training animals to use a tough cuff. They can train animals to present parts of their body to take heart electrical activity readings, and this is very beneficial because we know it can be an issue in some of our captive apes. And this is a quick video, and thank you very much to Stephen Shapiro over in Texas for letting us use this bit of data.
Turn around back. Turn around back.
And basically there's an implantable loop recorder in this animal which can detect abnormal heart activity. And This keeper has a small app on their phone, and they can basically take a reading very easily once the implant is in there and be able to use that information to monitor the health and welfare of that animal, which is really quite exciting. And I know I've touched a little bit on maybe recording sound and recording noise in the zoo, but zoos aren't just full of animals. We obviously have a lot of visitors as well, and that's something we really might need to monitor in terms of animal welfare. So what we can do is measure different elements of the environment that might then influence the welfare of our animals in our collections. So, for example, noise. We know zoos are very noisy places. A lot of them are in very urban areas with lots of people living nearby, lots of traffic, lots of noise that's very unnatural potentially for animals. So Kirsty and the team at Helsinki Zoo have very kindly sent me some information on them using an app called Ambicity, which you can use with an Android phone with a microphone. It's very simple, and you can download it very easily. And it basically measures noise during the workday, and it can take measures of noise every 5 seconds and has a GPS location as well. So what it means is that people, either keepers or even visitors, can walk around the zoo at different times of day and just measure what kind of noise levels we might have. So it might give you a noise map, and here you can see if it's higher in the red level, it's got a much higher decibel reading than those in the bluer level, so you can really track particular zones of your zoo that might be quite noisy for animals. You can look at very localized measurements at particular enclosures potentially, and you can basically look at exposure during different times of the year or the day as well, and it can give you some really simple readings. It doesn't have to be full of stats and lots of graphs and lots of numbers for you to be able to simply assess what's going on in your zoos. So the guys at Helsinki have sent me a little tiny bit of data. So a typical day in their zoo with school children, which we all know what that sounds like. In a general visitor area, it's about 70 decibels. In outdoor enclosures, about 50 to 65, so a bit quieter. And generally inside, it's about 50 decibels. So it seems to be much quieter. Whether they have signage to say, please keep quiet, maybe that works. However, at their tropical house, at their Gundi enclosure, they found that the noise level was between 70 and 72 decibels. So there was something about this part of the zoo, whether it was more exciting, although they do look like they're quite sleepy animals, whether it was something about that area of the zoo that maybe they need to think about a better way to mitigate that sound and look more into investigation of whether it really influences these animals' behaviour and welfare. And what you can also do is, this sounds really terrible, doesn't it? You can use GPS tracking to track your guests. So we'll talk about that in a few talks' time. But what we did at Paignton Zoo is we basically asked our guests to wear a GPS tracker. We asked them to turn it on at the beginning of their visit, and they walked around the zoo, and they gave us their tracker, and we could find out where they'd been and where they'd spent their time. And this is really beneficial for us, not only to find out which are the most popular exhibits, but also it can help really with master planning to see where people are spending their time and where the popularity is. But no surprise, they spent most of their time in the ape house. We're not particularly surprised about that, but it's really nice to have some data. And we found that there was a really significant correlation between body length, so how big the animal was, and attracting power, so how much time people spent there. And again, this wasn't particularly surprising to us. We know that people always like the charismatic megafauna often, but it's nice to have evidence of that. And then obviously we can then use that with the sound app potentially to be able to see where people are spending their time and then looking at different environmental aspects that again might be influencing those animals. So maybe animals that are more predisposed to having a lot of visitors around. So that's a whistle-stop tour of some of the technology that you might hear about today and some other aspects that you might want to go and investigate when you get back to your zoo. But I just want to highlight some of the aims of our plenary, what we really want you to take away from this. We want to introduce you to a range of technologies that will help you to assess and improve the welfare in your collections. And we want you to know that they're really easy to use. Surprisingly, they're quite cheap to buy. And you can use them for a real range of species within your collections. And we want to highlight some key scientific evidence for the use and application of these types of technologies in zoos, because we feel it's really important that we try and be evidence-based with our husbandry. And potentially there's elements that we can promote either within the research committee or within best practice guidelines for some really strong scientific evidence in how we can actually measure and assess animal welfare in our collections. Thank you very much. So I'm very pleased to introduce our first speaker, Professor Robert Young, who is now based at the University of Salford in Manchester, and he is the Chair of Wildlife Conservation. He started his career in zoos at Edinburgh, and he was a researcher there for 4 years, but spent a lot of time in Brazil lecturing and spending a lot of time at universities there. And if anyone works in environmental enrichment, you will have definitely read his book. It's kind of the Bible for enrichment, of which apparently a new issue is coming out soon, so it's very exciting. So I'd like to introduce Robert.
Great, thank you very much, Holly. Okay, so what I want to do is talk a little bit about some of the work that we've been doing and some of the potentials to use sound. So, moving on. So, thank you very much, EAZA and Sally Binding, Sally for organising my trip and EAZA for inviting me. The other people here are some of my co-workers, so I'm going to be talking about work that I do in collaboration with other people. Vinicius Goulart's one of my former PhD students. The next two, Paul and Bill, are actually acoustic engineers, and Marina Bonge is the latest PhD student to graduate from my group. And there are also contributions from other members of my research group in this talk today. And I'd like to thank my university for allowing me to come, especially during induction week, which usually when we have all the students, they want the staff around, so thank them. Okay, so what I'm going to do is give you a little bit of background about what animal welfare is, why we use sound, and then talk about what we can measure, give you some examples of the kind of things that we've been doing, the kind of things that we've been measuring, and then look at what's being developed at the moment, look at wearable technology using sound, talk a little bit about artificial intelligence and why that's going to become important, look at some problems of using sound, and a few conclusions. Okay, so one of the things I just wanted to clear up at the very beginning, because some people seem to have a confusion about what animal welfare is. So the difference between animal rights and animal welfare, very simple. Animal rights activists are campaigning for the end of zoos, whereas animal welfareists are campaigning for better zoos. Okay, very simple difference. So I'm an animal welfareist, so my work is directed towards improving zoos. Okay. So that's why, for example, as Holly kindly mentioned, I wrote this book on environmental enrichment that's widely used around zoos. So that's the position of an animal welfare scientist. We're here to help you, okay? We're not in the animal rights community, who are obviously opposed to zoos. So animal welfare is a complex subject, just like human welfare. There are many different facets to it, and nobody's going to pretend it's a simple thing to measure, okay? I'm not going to go into all that just now, but just to re-emphasize that. And one important thing to remember about animal welfare, just like your own lives, the welfare of animals goes up and down, okay? And we need to measure that, and the important thing is whether the welfare of an animal over its lifetime is positive, okay? And that's what zoos should be aiming for. It's not a problem that sometimes their welfare goes down, say, for example, when they're transported for a breeding program, okay? That's a normal part of life for all animals, wild animals, captive animals, as it is for humans. Welfare fluctuates, okay? So having cleared that up, normally when we measure behaviour and welfare, we've most commonly used the visual channel for a number of good reasons, mainly actually because humans are very visually dominated, so we've tended to use video and observe the animals, whereas we're moving more over towards using acoustics in combination with video for a range of reasons that you can see here. For example, sound is very good at going around obstacles, so we don't always have to be able to see the animals to understand what they're doing, and I'm going to give you some examples and explain about that in this talk. Okay, so one of the things important to remember, of course, is that our animals often hear in different ranges from us. Some of our animals can hear in the infrasound, so like your elephants. Some of our animals can hear in the ultrasound, like your bats. Okay, and that also means they communicate in those channels. If they can hear in those channels, they communicate in those channels. So that's very important. So sometimes we can be completely unaware that an animal is being blasted with very loud sound simply because our own hearing system cannot pick it up. Okay, so we as humans are very kind of biased towards our own world, and we need to always try and think about the animal's world. Okay, so sound we can use in many ways. How I got started in sound was actually measuring referential communication in primates in the wild. These are black-fronted TT monkeys, and black-fronted TT monkeys, when they see a predator, they're very smart monkeys. They actually do two very clever things. They identify the type of predator, so they'll go snake, to the group, and they'll also go snake below or snake above, or they'll go bird above or bird below. So they have a very sophisticated communication system which they use. Unfortunately, in zoos, as we don't usually present any predators to animals, we never hear this, we never see this behaviour. It's not normally elicited, which I think is a great shame because it's a wonderful behaviour ability that many primate species show. Okay, so moving on. You can see this is one of my field projects on the northern Murricky. This is my student, Marianne Kaiser, putting up some passive sound monitoring devices. You can see if you work for me, you have to work fast. There's no slouches in my group. I'm cracking the whip all the time. You know, I'm like Steve Jobs. I want this and I want it tomorrow. So what we're actually doing here, the northern Murricky that you can see there in the slide, this one here, he's actually called Robert Young. He's named in honor of myself. I actually thought he was named in honor of myself, then I discovered the students name all the monkeys after their supervisors. And I think it's so they can say things like, oh, yesterday we saw Robert copulating with Karen. So I suspect it was more about the joke value than actually being honored. So what we're using here are passive acoustic monitoring devices. So we install these in the field. We've got 2 microphones, one going out 5 meters this way, one going out 5 meters that way. We set them up in an array. We have GPS units in them so we can synchronize the time perfectly. And then what we can do is when the monkeys vocalize, so our target species, I do have a sound, but I don't think I'll be able to play it very easily for you guys. So when these guys vocalize, they have a very specific vocalization. We can pick it up on our microphones, and because I've got an array of microphones which are all synchronized, if several monkeys are vocalizing at the same time, I can not only say murrickies are vocalizing, but I can count the number of individuals vocalizing, okay, which gives me an indication of population size. So just to give you an example of how we're using this technology of bioacoustics in the field for doing conservation monitoring. And we also do camera traps, but the problem with camera traps, we have them up in the canopy. There are 2 main problems. One is 85% of our 200,000 pictures are leaves. So they're pretty boring to look at. And the other problem is they can only see a very narrow angle, whereas an acoustic monitoring device is working 24 hours a day, picking up for maybe over 1 kilometer of the habitat. So it gives us a much wider coverage of the habitat. Okay, moving on. So, and the kind of zoo wildlife interface, I've done some work with Gerardo, looking at golden mantella frogs with former PhD student Louisa Passos. This is still going on, some work. And we looked at the calls of the golden mantellas in the wild and the captivity, and we did some playback work. So what we did was we played back the calls of captive golden mantellas to wild frogs and vice versa. And what we actually found was that the captive frogs don't respond to the call of the wild frogs. And so we're now investigating with Gerardo why that's the case, and we're looking to find solutions for that particular problem. So, you know, there are sometimes problems there we don't actually realize, and that's ongoing research at the moment. So just to give you an example of how we can kind of interface bioacoustics between the wild and captivity. Okay, so one of the other things as a wildlife biologist that I became very interested in was noise, because you get a lot of noise in the wild. Okay, in Brazil, where I work mainly in the wild, we've got a lot of mining activity. The mines make a lot of noise. They're right in the wildlife areas. So, and my students start to tell me that in mining areas, the monkeys, like TT monkeys, don't vocalize. And we know that noise in humans has a very negative impact on their well-being. So if you look at the data on this slide, you know, you can see at least 8 million Europeans every year have sleep disturbance because of noise. And it results in over 40,000 hospital admissions and over 10,000 premature deaths in Europe alone. So we know that noise can have a very significant impact. So as I was measuring sound, I was interested to look at the effects of noise as well. One of the things that's important to know about noise, it's measured on a scale called decibels. A lot of people don't understand that the decibel scale is a logarithmic scale. So basically what that means, is every time you increase by 6 decibels, you actually double the sound pressure level. So what looks to be a small increase in sound level, actually for the animal is a very large increase, okay? So this is something a lot of people haven't really understood. And this is why it's very good to work with acoustic engineers like I do, because you can learn all these kind of things. So we've looked at sound pressure levels that zoo animals are exposed to. This is some work that we've done in Brazil with some of the Brazilian zoos. And so, but obviously I need to know, what is the baseline? Yeah? So what is the normal sound level that animals would be exposed to in the wild? So I went out and did technical measurements of the sound level in the Atlantic forest in Brazil, and it came out as an average of 38 decibels. Okay? So that's a kind of baseline. And I've also read studies in the African savanna which come out about 40 decibels. So it seems a lot of wild habitats, the average sound levels the animals are exposed to is about 40 decibels. There are times of years when you have cicadas and things like that when the environment can be very noisy, but in general, sound levels are actually quite low in the wild. And so if you look at the grey column here, what you'll see, and this is a range of species where we did measurements in their enclosures in the Belo Horizonte Zoo in Brazil, what you'll see is that the sound levels are up around 60 decibels. So actually these animals have been exposed to about 4 times as much sound as they would be in the wild. Okay? And this is on a day with zoo visitors, and we find the louder it is, the more active they are, the more alert they are. Actually, this is quite nasty when you start to think about it, because the visitors could subconsciously learn that if you're very noisy, the animals are very active. And what do zoo visitors like? They like active animals. So, and this is, the Belo Horizonte Zoo has an interesting situation where on a Monday the zoo's closed to the public, and so this is with the public removed, and you can see it's dropped down about 10 decibels, and so it's only about twice as loud now as the wild. So this is just with the keepers doing their normal activities. I think the important thing to remember is our zoo animals don't have somewhere often to escape from the noise that's being generated. So thinking about that, and these kind of problems, wanted to also look at zoos in the UK. So Marina Bonge, my PhD student, she's just writing a guide on how to do sound measurements properly. So that will be out soon. It will be a technical guide for non-kind of acoustic engineers, for biologists, how to do proper measurements. So hopefully if you keep looking for that next year, you'll see that out in press, which will guide you how to do these kind of things properly. So we've been looking at zoos in the UK, and interestingly, what we find in the UK is in general, public sound isn't a problem, but there is a problem in many enclosures in the UK, and what we see the problem in the UK is, you can see how wonderfully good I am with technology. 3 buttons and I can't do it. So what you can actually see is the big problem often in UK is the ventilation system or the heating system. So the heating system here, in this particular eye enclosure, is running at over 60 decibels. Okay, so this is a nocturnal animal used to a very quiet habitat, and it's about probably 4 times as loud it would normally experience in the wild, and a sound-sensitive creature. So when we look, the human sound isn't actually particularly significant, where is it here, in comparison to the heating system. And a lot of places might not be aware of this problem because the heating system comes on at night when everybody's gone home. And so people are not actually hearing this particular problem. Okay, so as I mentioned to you, one of the problems for zoo animals is they can't avoid sound. So would animals avoid sound if they could? So what I did to test this idea was I looked at sound levels in city parks in Brazil, and we looked at biodiversity. And what we found is the biggest predictor of biodiversity, the number of species in city parks in Brazil, was the sound level. Okay, so what we found was that sound-sensitive species move away from noisy areas. So it does show us that if animals can, they will move away from noisy areas. And actually I've done studies on primates which show exactly the same thing as well, that primates move away from noisy areas in the wild. So, we need to think very seriously about those kind of things in terms of the well-being of the animals. Okay, so what else can we do with sound? So where people are really interested now in going with sound is looking at other more sophisticated measurements. So looking at more specific behaviours, looking at using sound to record physiology, and looking at sound also to record the environment. And sound has a lot of benefits over, for example, video, in that video only really gives us behaviour and environment, and sound can also give us things like physiology. Recording sound in a zoo environment often gives us less privacy issues in comparison to video. Because of the public. High quality microphones are small and cheap, so the technology is relatively cheap. And in terms of data processing, the files are much smaller, so we can use lighter devices with animals and things like that. So it's a lot easier to process the data from sound than it is from video. I do still work with video, but that's another story I already talked about in this conference. But sound's definitely got a number of advantages. So what kind of sounds can we record? So what we're talking about here is actually putting devices on animals like collars to record what's going on. We can get direct animal sounds, indirect animal sounds. I'll give you some examples of that. Physiological sounds. So the graph here is actually sound recording of an animal breathing. We can get environmental sounds. We can record other animals, and we can record the environment. So direct animal sounds, we can get very obvious things, the vocalizations, yeah? So the loud calls, but we already usually hear the loud calls of gibbons and titi monkeys and howler monkeys. You know, we pretty much hear them anyway. But a lot of animals actually make quiet calls. So the titi monkeys that I work with in Brazil, they make a lot of quiet calls to each other. And you never normally hear them in a zoo because you've either got glass in the way or you're too far away. And I think it's a bit of a shame that the public don't actually get to hear them. So, for example, when titi monkeys go very close to the ground, they usually go this kind of tick, 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 tick call. And it seems to be like, I'm in a dangerous situation, I'm in a dangerous situation, I'm in a dangerous situation. They're kind of warning the others, yeah? And, you know, we just never hear it because it's a very low call. In the wild, I hear it because we've got very habituated groups we can get close to. With sound, we can hear emotional states. So a lot of animals, when they're distressed, all mammals, when they're distressed, make non-linear vocalizations. Do you know what a non-linear vocalization is? So you know if you try and scream really loud, and sometimes it comes out, and then sometimes your voice disappears, and then sometimes it comes back again, that's a non-linear vocalization. All mammals do that when they're in severe distress. So it's a very kind of characteristic thing of distress. Some animals have vocalizations which indicate pleasure or happiness. We can record those. So we can access some emotional states through sound. And many animals have other kind of vocalizations. So they might have a food call. I've already talked about predator calls. A lot of animals, when they copulate, they have a copulation call. And a lot of animals have greeting vocalizations. So we can actually find out quite a lot about what's going on in an animal group by recording the sound. Okay, so if we look at indirect animal sounds, that reminds me to drink. We can actually hear, if we have a collar on an animal's neck, we can actually hear them eating and drinking, yeah? And so we can hear swallowing, chewing, and the rate of swallowing and chewing and the frequency probably relates to the quantity of the actual food and whether it's hard or soft food. This technology is already being developed for ruminating animals, domesticated ruminating animals. There's already some equipment out there. And there's a lot of ongoing research into this in humans to record feeding behavior. Why? Two main reasons. One is the obesity crisis, because people always lie about how much they eat. Just like people always lie about how much alcohol they drink. You go to the doctor, oh, how many units of alcohol do you drink a week? 10. The doctor knows, multiply it by 4, yeah? So there's a lot of research going into that. People had tried to develop cameras on glasses, but they're very impractical and they have lots of privacy issues. So now what people are really working on is recording the sound of people eating to work out how much they're actually eating. And the other big issue that there's a lot of interest in is with people with dementia. People with dementia and those kind of diseases often don't know if they've eaten or drank. So it's a way of monitoring those kind of issues. Okay, and physiological sounds that we can record. So heartbeat, we can actually use a microphone, we can listen to the heart beating. We can look at heart rate variability, we can hear heart murmurs, we can listen to respiration. Obviously all these things vary with physical activity, so we can listen to how they vary with physical activity. If in terms of respiration, we can hear apnea, we can hear whistling, all these things might indicate a health problem. Certain types of abnormal behavior, like wing sucking, we would be able to hear as well and identify. Stomach rumbling, if you haven't had breakfast, we all know that indicates hunger, and we can hear conditions like teeth grinding and a whole range of things. So there's a lot of possibilities that we can use sound to actually pick up behavioral problems and welfare problems. And potentially, we can use sound to pick up certain types of environmental sounds. So if you think about locomotion, providing you've got a hard substrate, you can actually pick up the footsteps of an animal, and then the frequency of those footsteps can indicate the type of locomotion, the speed of locomotion. Certain types of ritualized behaviors will have very fixed patterns like dances. We'd be able to pick out those patterns. So it might be a courtship display or something like that. We could pick up pacing, yeah, which will have a very fixed rhythm to it. So types of abnormal behavior, but of course this all depends on the surface that the animal's living on. If they're on very soft surfaces, we're not going to get any sound probably being emitted at a sufficient level. So sound does have a number of applications in that way as well. And of course we can use sound to identify animals, other animals around an enclosure. If you had a mixed species exhibit, which animals are nearby, which animals are vocalizing. We can use sound for individual identification, count individuals, identify age and sex and things like that. So sound has a whole use of arrays beyond just recording the animal itself. The animal itself can be a walking microphone around the enclosure, recording other things for us, including the environment of the enclosure. So we know when it's raining, we know when it's windy, as I already mentioned, the other animals, and things like anthropophony, so human sounds, yeah? So your animals in your zoo, I already mentioned earlier about the impact, yeah, of noise pollution. We can actually hear directly how much traffic sound, what frequencies are actually arriving to the animals. Can the animals hear those frequencies? We can hear machinery. So often there's machinery working in your zoo, which might be things like heating systems. It could be canteens, so ovens, things like that. It can be light systems, which are all causing sound that we're not particularly aware of. So we can record all this and find out exactly what's reaching the animal. And we can also hear how much sound visitors and individuals like that are actually producing, and how much of that is actually arriving on the animal. So there's a whole host of things that we can do. So how's this been done at the moment? So there's been, particularly in the pet industry, there's been a lot of development of wearable technology recently, and if you've got a cat or a dog will know this. This is some equipment that we've been using. This is a collar called Pet Pace. It's been produced in Israel, and it has basically 3 sensors in the collar. You can see it's quite a small collar. It has a microphone, which basically measures heart rate and respiration, is what it's listening to. It has an accelerometer, as Holly mentioned, so that allows us to look at activity, sleep and rest. And it has a temperature sensor, so it actually looks at body temperature. So I'm not saying that a sound sensor on its own is the best thing. It's a combination of using sensors together, which will give us a very good idea about what's going on in terms of the behavior and well-being of animals. And what happens in this particular system is that the data is transmitted over Wi-Fi. So for a pet owner, you have a unit in your house. I use this on my pet dog. Every time, about once every hour, it transmits his data over the Wi-Fi to an app online, and then from the app online, I can draw these kind of graphs and I can look at their behavior, their heart rate, their respiration, okay? And this is all done in a very automated, easy way. I can also have this on an app on my phone. So you can use this wearable technology. As I mentioned, it's been developed really for dogs and cats at the moment, but it should be adaptable for other species. So one of the problems with all the stuff that I'm talking about is it generates a lot of data, okay? So I'm not going to pretend that dealing with a lot of data, you guys are working in zoos, so you have loads of data, I know that, is easy, but there are ways and means to deal with this and automate the processing of this data. So if we go back to the Pet Pace system, you can put in parameters for alert. So for example, you can put in a maximum heart rate or a minimum body temperature or a maximum body temperature, and the app will actually give you an alert if the animal goes outside those ranges. Okay? So you don't have to be sitting there monitoring it, it will automatically monitor for you those particular parameters. Okay, so in terms of processing this, you don't have to worry about this bit, but I just wanted to tell you how it's done, just so you understand. People are now using AI, artificial intelligence, to actually process all this data. So when I first started using sound in studies, do you know what we did? We recorded all this stuff, we gave it to our students and said, have a happy few months listening to the tapes. Yeah? The problem was that used to drive our students insane, and we're not allowed anymore in the university to drive our students insane. I don't know why, but apparently it's not good. So what we've had to do is come up with automated methods of doing this. So the acoustic engineers that I work with, not only do they advise me technically, but they also write for me software that actually automatically processes all our data now. So do you remember those muriquis that we're doing, in the wild in Brazil? So we don't listen to thousands of hours of muriqui vocalizations, or in fact, the rainforest in Brazil with the odd muriqui vocalization. A computer program does that for us. Okay, so my student is not driven insane having to listen to all that stuff. It's done automatically, and that's using AI. And it's pretty much the same thing on your phone. If you've got an AI phone, my phone's got a lot of AI on it. It's a very kind of simple, similar kind of system that's used. Okay, so as I mentioned, we use these kind of sensors, sound in combination with other types of sensors. So it's not going to solve all the problems on its own. And you can combine, as you saw with the pet pace, other sensors, depending on what particular thing you want to look at. But the thing is, don't include the kitchen sink. We don't need to put everything on. Yeah, there is a bit of a tendency with technology to think, oh, we could add this, and oh, we could add that, and oh, yeah, and suddenly you can't drive anymore because you can't see the screen of your car, yeah? So we do need to use technology in a very rational way, okay? We need to really think about what we're trying to do and what we're trying to measure. Otherwise, we're just going to create problems for ourselves. Okay, so the good thing about all this is training computers to process data is not too difficult, so I don't have to worry about driving students mad or anybody else mad anymore, listening to thousands of hours of rainforest, and that's all done, as I mentioned to you guys, by artificial intelligence. The tricky part is really training computers to identify the sounds of specific individuals is very easy. So when Vinicius, my PhD student, was developing devices to listen to people, we used humans because it was easiest at the beginning, eating and drinking, within a day he could train a computer algorithm to identify when he was eating or drinking, okay? That's very easy. The problem is getting an algorithm, the computer trained to identify for everybody, yeah? So getting an algorithm, getting the computer to understand all the variation between individuals. So you've probably all got, and I'll say those terrible words, okay Google, and probably half your phones have switched on. Yeah, my phone's just switched on, which is now covering up my stopwatch, which will allow me to go over time. So okay Google works really well because Google have about 1 billion samples of human voices. Okay, and that's why they can get it to work. Even if you've got a very thick Irish accent, Scottish accent, Southern English accent, whatever, yeah, it'll work because they've got billions of examples. And so very easy to get it work for individuals. It's much trickier to get it to work in a kind of general sense like that. There are some data sets already available we can use for training. So there is an audio set with over 2 million sounds available, which can help us, and there are already. So if you want to do this stuff yourself, there are already pre-programmed algorithms out there which you can modify. Great advantages of things like these sensors are very small. They weigh just a gram or a couple of grams. They're very cheap, from £3 to £40 usually. And one of the things, if you want to be involved, many cities around the world now have innovation spaces. I don't know if you've ever looked at this. I think zoos sometimes too focused inward and not enough looking outward. So in Manchester, for example, we have a place called Mad Lab, which is very appropriate because people like me are there, yeah? And it's full of geeks and nerds who build devices and do programming and stuff like that. So if you don't want to buy stuff off the shelf, like the pet pace, you want to make something very specific for one of your animals, you might think, well, we don't have the skills or the time to do this. You could go to one of these innovation spaces in your city and see if some of the people who are there, they're usually just amateurs, are actually interested in developing stuff like this for you. Okay. Of course, the problems, I've already mentioned, training set needs to be very large. You can get too many signals, so too many information sources, so you need to choose the ones which are actually important for what you want to study. Infrasound we can't do at the moment. The equipment's just too heavy. You wouldn't be able to put it on any animal. The equipment at the moment, as you probably know, we can't put anything on an animal that's more than 3% of its body weight, so that can have certain issues with certain smaller species. Necklace animals, so like tapirs and animals like that, are a bit problematic, yeah, because collars just come straight off. Battery life can be an issue if you've got very small animals, because computer chips are actually consuming quite a lot of batteries, so they can need changing quite frequently, but batteries are improving all the time. And in zoos, usually you guys have all got Wi-Fi, so you can just have the data transmitted over the Wi-Fi. You don't have to capture the animal. You can just have it transmitted all the time. But if you've got a very noisy zoo environment, a very loud heating system or a very loud ventilation system, it might mask all the sounds the animals are making. But if it's that loud, you probably should change that system, because it's probably causing a welfare problem. Okay. So I think using sound is very interesting. I think it's often more practical than using video. As you can see in this video, imagine trying to teach your cheetah to run around with a selfie stick, to make videos of itself. I think that, you know, I would rather just put a collar on it. I think that, yeah, I'm sure some of our animal trainers could do that, but I think it's not very practical. I've shown you that sound can measure behavior, physiology, and environment, that it has other advantages over video. It needs ground truthing, which means that we need to check it against traditional measurements, which is what my research group does. It's not suitable for all species, and it won't recognize all behaviors. There's a lot of products in development. There's a lot of products already out there that you can use and adapt if you don't want to kind of build your own bespoke products. And there will be more and more products coming out. There's a lot of stuff in development at the moment using sound for doing these kind of measurements. And so just to thank you all very much for listening, and hopefully I haven't scared you too much with technology. Technology can be very positive. Technology, whoops, can we go back to that slide, please? Can we go back to the last slide? Technology can also be a bit negative. As we all know, we need to use technology in zoos in the right way. And before you ask, yes, that is my son. And yes, that is a wild maned wolf. And I'm going, Will, have a look to your left. And his response is, Daddy, I've just got a signal. Shut up. So if you have any questions, I'm going to get Will on a video chat because he's a teenager and he has the answer to everything. Okay? Thank you very much.
Thank you very much for a wonderful, inspiring talk. I'd like to introduce our next speakers. Oh, you guys want to come up? So this is Dr. Lisa Holmes from Chester Zoo and Graeme Dick from Longleat, and they are the co-vice chairs of the EAZA Animal Welfare Group.
Okay, thank you very much, Holly. We're just going to take a short amount of time just to talk a little bit more about this nanotechnology, so GPS technology, and then give you some actual examples, not just from zoos, but from other published data as well, because there's actually very little published from collections, particularly across EAZA. So don't be afraid to look in the literature at other, farm animals and laboratory animals, because sometimes they can give you clues to how you can use this technology. So we'll focus on RFID technology, accelerometers and GPS, and give you those practical examples. And then Graham's going to talk a little bit about some of the data that we've collected during this conference. So if you think about technology, tracking technology over the ages, actually it started with bird ringing. So perhaps not technology as we think of it now, but bird ringing was used in the early 1800s, and that was a way of tracking migratory patterns of birds, and it's still used today. In the 1940s, migratory birds were also picked up on sonar radar signals, so that was a very early way of actually tracking animal movement. And this is one perhaps we're more familiar with when we think about our field studies, is actually using radio telemetry. So using these acoustic signals that are emitted every 1 to 2 minutes, and you would use an antenna to pick up those signals, sometimes over 1,000 meters. So great range, but sometimes it can be quite tricky to pick up the signal of animals. So the ones we'll focus on will be the RFID tags, or PIT tags as they're known. This is another example of nanotechnology, so the technology that's becoming so small that we can actually use it on very, very small animals. As Rob said, we can't put anything on an animal that's more than 3% of its body weight, so this nanotechnology is fantastic. Accelerometers are very, very small microchips. I was actually in talks with the University near us in Manchester recently and actually saw how small and how light these chips are, so they're very easy to use. And then GPS collars and anklets. So anklets and bracelets are becoming much more popular in the use of GPS tracking. So if we think about RFID, or radio frequency identification, it's used to transmit a signal. It's very passive, so you don't need the batteries. That's one of the main things that we do when we're using any kind of technology in our collections, is that if you have a battery and it runs out, you might need to access the animal every day, which isn't always that practical. The thing with RFID is it does require close contact with the receiver. So it might not pick up the signal if your animal's quite far away from where you can actually put those receivers, whether they're around the enclosure, or you might be able to put them on perhaps a nest site. That's usually the best way to detect them. But they're relatively inexpensive now because the technology's been developed for a long time. Generally, they're actually put under the skin, so they're subcutaneous, so it is quite an invasive measure. But you can use this technology actually non-invasively. So for example, if you're doing this with any tortoises, you could glue this to the carapace. But what they're probably most commonly known for is actually used for microchipping domestic animals, and you'll see it a lot in laboratory animal literature as well. So if any of you have got a cat flap and it enables just your own cat to go through there, it's because it's using this radio signal on the chip that the cat has. So they're very, very useful for actually limiting use to a certain area, perhaps of an enclosure or a nest site. If we think about accelerometers, as Holly has already mentioned, they're sensors that monitor body movements, posture and orientation. So that's done in 3 different ways. So sway, a lateral movement from side to side, surge, which would be front to back, and then heave would be up and down. So if you think about your mobile phones, when you tilt your phone and it knows instantly which way up your phone is so that you can read a document, that's because it's got a built-in accelerometer. So it's the same type of technology. And actually, it's possible to train the computer software that you use with this to detect behaviours. You need to validate it with some video footage perhaps, but you don't actually need that much. And you get a pattern of the signal, and then you can say whether the animal is moving, whether it's jumping, just based on that signal. So it actually, if you train the software, you don't actually need to watch your animals. You can just use this accelerometer to collect your behavioural data. So it would save a huge amount of time and a huge amount of students' time as well. And I just wanted to put this paper up. This is a fantastic example of how you can use accelerometers. It's a really good worked example, so it's a fantastic resource. So now if we focus on Global Positioning System, GPS, so it precisely times the movements with satellites in real time. So originally, the signals would actually be stored on the GPS system, and it would have to be downloaded. So everything that you would collect would actually be retrospective. So it tracks patterns of movements. But you can also use it for social behaviour, so looking at proximity of individuals. So it might be individuals of another species, it might be individuals within another group. So if you think about how you could use that in a mixed species exhibit. And they can be used in conjunction with accelerometers. So you would get the location data of where your animals are, and then also what they're doing as well. So you can generate a lot of data. So this is a photograph from Disney's Animal Kingdom. It's actually taken from a special edition magazine from EAZA on promoting positive welfare. And you can just about see just under the ear the GPS collar there. So they're becoming a lot smaller, a lot less cumbersome, but a lot of the technology now is actually being developed so that you can use bracelets and anklets, so they're much less obvious to the guests when they come to the zoos. So if we start looking through at some examples, if you think about how you might be able to use GPS technology, if you were looking at activity levels, so this is actually taken from some livestock examples. This is a dairy farm. And what you can see in this first picture is the dots from where the animal has moved around. So this is in the yard here. This is where the feed would be provided. And then these colours here just show the speed of the animal. So you can actually detect how they're moving. So this is 17 dairy cows with GPS collars. They took data 10 days over a 3-week period. And just as we would expect, the cows were actually spending most of their time near the food and water sites. But they could actually detect behaviour from this without using accelerometers, just by looking at the speed. So they knew that the short speed and the shortest bouts on this picture here actually showed that they were foraging. Whereas when we have this higher speed with longer bouts, that's when they were actually searching for food. So this is a really nice example to say, this is how you can monitor really basic behaviours. If we wanted to look at walking distance, this is a fantastic paper, again from North American collection, but it's actually over 40 different zoos. And they did this with Asian and African elephants. And so there was 56 elephants with GPS anklets this time, not collars. And they actually found that locomotion decreased with a predictable feeding regime. So they're not doing that searching behaviour. The distance that they were actually travelling decreased with age, so the older animals weren't travelling as much. So again, it might be a pattern that we would expect, but we have the data now to show that. But the most interesting finding on this paper was that there was no correlation between the distance travelled and foot or joint health or body condition. And we would make that assumption that actually if we do have a foot problem, we might see that they reduce their locomotion. So it's a good way of thinking about how can we combine all these measures? How can we actually interpret the data we're getting? If we wanted to look at home range, so if we're thinking more about wild animals perhaps, this is actually an example from European badgers. So again, don't be afraid to look at non-exotic species when you're looking at things like this. But this was taken from 48 wild badgers tracked over 7 years in Ireland. And they actually found that 20% of the males had these super home ranges, so over 4 kilometres wide, compared to the average of 1 to 2 kilometres. And that was maintained for up to 3 years in some cases. And this had never been detected before, this had never been seen. And actually the males were crossing 2 or 3 male territories. So this was really interesting behaviour. What they actually think is that it was increasing their social interaction and perhaps access to breeding females at the time. But it just shows how we can look at perhaps, if you've got large exhibits, you've got mixed species exhibits, you might be able to use this technology just to see how the animals are interacting, which houses they're using as well. And in this case, the authors talk about how we might look at disease transmission if the animals are moving around a bigger home range. Thinking about now access to resources, it's another elephant example. It's the same research group that Holly showed you earlier. But this paper is actually looking at the social structure of the elephants and how that influences what they use within the enclosure space. So again, this was at Disney's Animal Kingdom. San Diego Global have done some very similar work recently. And they found actually that the dominant female monopolized the watering hole. So they can do that just by tracking her location. But the subordinate females, so the lower ranking females, avoided the narrower areas of the enclosure. So that made them think about how they use their enclosure space and whether they needed to gain access to certain resources and whether they should make a change. So it just shows the impact of social rank on access to space, and again using this technology to detect that. I talked yesterday a little bit about nocturnal behaviour in the sleep session that we had. But this is actually one of Rob's studies from a few years ago, where they were looking at maned wolves in the wild. And again, using GPS tracking collars, they looked at an adult breeding pair and a juvenile daughter. And what they actually found was they could detect when the breeding pair actually had pups because the female stopped moving. So every night she would go out and she would hunt, but as soon as she stopped doing that, they knew, right, there's something going on here. Actually, she's had a litter. So it can actually tell you a lot about what's going on with the animals. They also found that the adult female had the largest home range, so it overlapped with the other individuals, and that they hunted individually at night, but slept together during the day, and that they were tolerating the juvenile daughter even though they had pups as well. So it's a way of describing what you're seeing with certain animals. So if you've got nocturnal behaviour, you've got elusive animals, you can detect an awful lot by using GPS. Okay, I'll hand over to Graeme now.
Okay, so we wanted to sort of try and demonstrate with a practical application to try and put the theory about what we're hearing about today into practice. So a few days ago, while we were enjoying our wonderful tour around Attica Zoo, 10 of your colleagues in the room were being GPS tracked. So we asked 10 of the willing volunteers. We didn't give you much notice, so I do apologise for that. We sort of jumped on you before you got on the bus. We try to spread people around from across some of our members, so we have a nice spread of countries represented there, and that was to try and ensure that we didn't have a bias towards sort of one particular country that always head for the bar direction. So we wanted a nice spread, and actually we got some really interesting results. So there's the tracker there that we used. We deliberately kept the Brits out for this one. So this is the tracking unit here, only a couple of inches in size, that just clipped onto the side of somebody's pocket or their bag. All the volunteers were willing. We didn't force anybody, just to put that out there. So this is some of the results that we've started to get through. We've just done a basic analysis of some of the results. The technology allows us to do a lot in terms of altitude and distance and rest time. But we've had a little look at, we've kept it anonymous for this as well, just to say that. So you can have a little look at certain areas of these two candidates where the activity levels dropped dramatically when they got to the bar, and also when they got to the dolphin show as well, which is what we sort of expected. And when we have a look at the delegates that we tracked, everyone has a different colour, and I apologise, it looks a little bit like a mind map. Some delegates particularly started at the entrance of the zoo down here and went straight for the bar in the middle. Some of the delegates actually walked around the entire perimeter of the zoo first to get their bearings, and then ended up in the bar. And if you have a look at the locations of high activity levels, so areas such as the bird show just up here, and the dolphin show, and then some of the primate enclosures and elephant enclosures up here. So it's just quite interesting to see some of the movements, and everybody was very different, which was really nice as well. Now, this has several applications. As Holly said earlier, it was used in Paignton Zoo to look at visitor activity levels. We looked at sort of where we expected people to go, which was the activities that were put on, and the food and beverage, and the toilets as well, but we've fuzzed that bit out. And actually we found that there was a really nice spread. So everybody that we chose had a different understanding of what they wished to achieve when they visited the zoo. And if you looked at this similar to how you would look at an animal enclosure, we had quite a nice spread out of areas, but there certainly was high activity areas where food and enrichment were offered. So it proved a point with the delegates. So this is just another example. The red dots that you see there are moments where the candidates or the delegates stopped for longer periods of time. So there are a few that are a little bit more surprising. But if we have a look at some of the routes, the person in pink here did the full perimeter search, and the person in blue just stuck to that middle route in the middle. I'm not going to put names on it, don't worry. And then just to show some of the other functions of the technology here, we highlighted the pink person because this was the marathon runner out of the group. And you can see that they actually spent some good periods of time at areas that weren't the dolphin show and weren't the bird show, either chatting quite heavily to other delegates or particularly interested in certain animals. So this one actually spent about 43 minutes here around the primate enclosures. So you could surmise that they potentially have an interest in primates. And somewhere in the middle there, they spent about 3 hours and 40 minutes at the bar. Before they went home. What was really interesting was some delegates as well also left their trackers on when they went home, so we saw exactly where you went. So I'll hand back to Lisa to just do a summary. That was just to add a little bit of fun into some practical applications, and thank you very much to the delegates that were semi-coerced into performing for us.
Thank you. So yeah, we just wanted to sum up and just say that actually tracking technology has a variety of uses in monitoring welfare. You can look at activity levels, you can look at distance travelled, you can look at those preferred resources and social behaviours, but it's also really useful for health as well, because if we're looking at posture and gait, which we can actually get from accelerometers and GPS, it could be useful in the veterinary industry. It can save time and it can generate a lot of data. So as Rob said, that can sometimes be quite difficult, but actually if it's automated data, it's going to save a lot of student time. And it can be combined with other measures. So don't think we're trying to replace, those behaviour studies, we're trying to replace other things that we're doing in terms of physiology measures. It should be used in conjunction. It's another piece of the puzzle. And we just wanted to thank again the people who'd done the GPS tracking for us. There you go.
Thank you very much. And again, I'd like to also say thank you very much to the 10 willing volunteers that we had, although some of you didn't look very willing when we approached you with a little piece of plastic box. We have our final keynote, who is Dr. Gerardo Garcia from the Chester Zoo. He is the Curator of Lower Vertebrates and Invertebrates, and is very integral to a lot of the breeding programs that we manage on reptiles and amphibians at EAZA. And he's going to talk to you about thermal imaging.
Thank you very much. Good afternoon, almost afternoon. Right, are you hot enough? Yeah? I bet you are, especially after all this walk around the pub. I'm going to give you a little introduction about this use of the thermal images and the thermal cameras. So many of you are already working with them for many years, and other ones maybe feel a bit scared about these kind of tools. But I'm just going to try to convince you that it's another extra element. It's not the magic trick, grill. It's not going to solve the solutions, but it's a very nice key to continuous working with your animals in captivity and as well apply on the wild. But in particular today on the talk, we're going to talk about the application for animal welfare, husbandry and veterinary. First slide is going to be a bit more technical, just orientated, because I needed you to start working in this talk, and your eyes, it has to be focus in infrared. So I needed to convert it a bit on the infrared. And in the electromagnetic spectrum, you can see on the graphic here, we have the visible light. This is what we can see on a daily basis. And it's right at the end, we have the infrared. This is the extra skill that you're going to build up now in your eyes, and you're going to be able to see beyond what it is in the normal basis. What is the thermographic cameras? What it basically do is, detect the radiation that produce objects. So basically, it's receiving all the information that is producing that objects. And we're working on the wavelength. And you see the wavelength here. That will be the visual part of 0.4, 0.75. As soon as it's infrared, we jump now to 8 to 14 micrometers. That is the two different range. So there's a little gap in between that we don't have it between the infrared and the visible ones, but it just fits very well. The thermal cameras, they give you the option that you can see during the day and night. And it's an option that it gives you much more flexibility when you wanted to monitor your animals. So it's something very important to do. And as well, you don't need it to have extra artificial light, which it doesn't change the behavior of our animals. The temperature range that this equipment can do varies obviously with the models, but it can go from -20, even more in some of the cameras, to up to 400 Celsius. And the accuracy of the resolution that you have it in that case is 0.1 Celsius. So it's pretty good in terms of getting really close. There is a little bit of challenges in the technique of that, but we will see through the presentation what we needed to make sure that we maintain that resolution. Then how it works, we don't go too complicated. Let's make it very simple. There is you can see a dissected thermal camera right on the top. And what it basically does is measure simply infrared energy from the objects that is rejecting all the information. So what it converts is the infrared data in an electronic image. That's what you can see in your screen. This is what you can just print it. That is the information you receive from infrared data to an electronic image. What it does is when you have the energy that it gets through the sensor, the lens gets sensitive, each pixel produces a reaction and it produces a signal. The signal goes to a receiver, the receiver just converts it, and what it does is in a mathematical calculation, or every single signal they receive produces a map. So we leave it all to them. What we see is a visualization of the data. But it means that every single value of the temperature is a color. So each dot or color is a specific point of temperature. We can change the coloration depending on the flavor that you prefer to have it in the printing. But basically, every temperature value is deferred to a color. When you produce all these colors in a matrix, it's the vision that you can see, it's the image that you receive in your screen. But it's a conversion of data. How we use this technique, and in fact, it's been in the market for a very long time. Particularly all started on the military application, and you probably have seen it many times. There's obvious reasons why militaries will like it to use, or they use extensively the thermal images. Construction, that is something that you haven't done, and you have a thermal camera. I invite you to depress a bit to get out in winter and get your house and see your roof. You want to see how your heat and your electricity bills is coming? That is what it gives you. And that's when it comes to all the constructor and start giving you the sales. You need to insulate your roof, your windows, double glazing. This is what they use. This is the construction element. In the industry, you have it as well in a regular basis. Electricians, engineers, they use on that. When you have a fuse board, they use it in a very regular basis. With the thermal camera, it can identify the heat that is producing all the different equipment. So it's something that has been on the market for a very long time. So the commercial value of these images have been very important. Medical diagnosis as well. So this is something as well in the human medicine is being used for a very long time. And it can be for inflammatories, can be for following treatments like, post-treatment of cancers. You can just really see how it's swallowing, and you can just follow in at that. Equally, obviously, with the academic research or anything that you wanted to collect information on temperature and you don't want it to be intrusive, which is the key component in this tool, you use thermal images. And the word no intrusive, it will appear and repeats in many cases. You will see that is one of the major reasons why many of you have been using this tool. It's just to avoid the intrusive element, the disturbance, and the stress of the animal. And that is what we consider is a very nice complement tool for your equipment. The research is amazing, what is being done. And that is a very interesting paper that has been published. So you can identify who is drunk by having a thermal camera. Obviously, I'm not going to take it tonight, so don't be scared. But you can just map, obviously, with the whole process of reading and training the software in the same way that Rob talked about this song. But you can see that sclera is one of the elements that increase the temperature when your levels of alcohol is a bit high. So you can identify how many levels of applications you can have with these techniques. But we're not going to go in that road. This is only just as a little detail. What we are more interested today is talking about the application that we have for veterinary medicine, ecology, zoology, all the elements of natural science. And this is the wide range of applications. As a general topics that we will have is injuries, inflammations, infectious disease, controlled reproduction, and lactation process. Remember all the time that what is reading this is the temperature of the surface. We're not reading the temperature inside the body. This is not used. We needed all the different tools. It's all what is radiating. And I'm sure after the talk, you will be able to interpret what's happening with the typer. So at the moment, it probably is a bit ambiguous, what is so white, but I'm sure you will pick it up really quickly. Right, if we go a bit narrow, and this is slowly we're getting through the focus of the talk, is about what we use with wildlife, and it's been used in many cases, and well-known foot and mouth disease, or rabies infections in raccoons, the controlled reproductive process in different animals, in Asian elephants and rhinos. Of course, this can be a complement. It's not just a resource and an only way to continue, but it can help you in certain cases. And one wide range of topic that you can have is a thermal regulation, which is absolutely vital in our institutions for the whole range of taxa. So everything that could be measured, you will see later with all the different examples, you can see how useful could be to understand, interpret, and adapt the management of your species thanks to these tools. And then obviously an analysis of animal behavior as well. So you will see different studies that has been done to understand the behavior of the animals thanks to the thermal cameras. And another aspect which is slightly connected to our animals when we have it in our institutions is the detection of animals. So obviously you can detect it in your institutions, we can detect it in the wild. So the element of validation of this technique to apply in the wild is essential. So that is kind of a specific topic that it requires a specific time. So we will leave it in one side, but just thinking that most of these tools and examples could be easily applied for monitoring populations and even estimating population size if it's so precise to identify the individuals. So I give you an example about how you can apply these kind of techniques. A very attractive research, which was comparing between hornbills and toucans. Surely many of you have done this. And it's pretty interesting thing about the way how the hornbill, in that case, this is the ambient temperature. Can you read 15 degrees Celsius? Yeah. So you see the beak maintains the same temperature, the ambient. When it starts increasing the temperature, the beak as well, but the lower part starts raising temperature. Something is happening. The bird is changing its behavior and is reacting to the environment. When you increase the temperature to 32.2, only just 2 more degrees, not even, what it changed completely is now the beak is higher temperature than environment. So the animal is start exposing, it start radiating heat from the body. It's getting too hot for the hornbill. What it produces when you go even higher for 43 degrees Celsius, the animal start evaporating the water. So they needed to just empty all that heat that they have on the body, and what is by the evaporation is cooling down the beak. So that's interesting, the way that and species that live in dry areas in Africa, how react with the different changes of temperature. The same experiment is being applied with toucans, which live obviously in different types of environment, much more humid, and the trigger point is not so at 32 degrees, it's slightly lower. So toucans needed to start exposing the heat faster and earlier than it will be on hornbills. Thinking that it will be, well, this is probably only just pure science and you're playing with the bird. But it's interesting to know and apply when you're developing your new facilities or your new enclosures, the element that is going to trick the behavior of the animals and how it's going to respond if you put it to extreme conditions. So it's quite an interesting one. So now, having all the overall about understanding thermal cameras, the techniques, how you can apply, what I really needed is that you start to getting the extra spectrum of your light. So you need to start moving from the visual to the infrared. And you probably remember this gentleman. You remember Predator? So that is what you needed to start thinking. You now have to keep it in your eyes that your vision start to become infrared. So you needed to start thinking about what is normal vision and is infrared vision. And in all the cases that we're going to see from now, you will have the possibility to pick what is going on. Okay? Are you ready with infrared? Good. That's what you still start seeing. Can you see that in colors? Yeah? Good. So you are in infrared level now. From now on, animals we're going to see in that level. We're going to start seeing all the birds, mammals, all the range of the species and different gradients. And you will have the possibility to change colors because you can play with the different palettes of colors as well, depending on your flavor. Okay? First of all, thank to everybody that has been responding so nicely from tags, EAP coordinators, researchers, when I ask about sharing experience. I'm going to give you a little flavor about the numbers of different experience that all of you have been shared with us. We will be elements from how to monitor temperatures and environments, how thermoregulated animals, assessing welfare, behavior, all different levels, and one a wide range, which is the part of the veterinary. Definitely vets are ahead of the game in this. They've been using this tool for a very long time. So all the normal practice, following animals, checking that the animals is recovering, veterinarians have been quite wide represented this. The kind of tools and equipments can go for the very tiny little accessory that you can plug in your Android or your iPhone to a much more sophisticated cameras. And we'll talk later about the pros and cons on these ones at the end of the talk. But that is the kind of examples that I'm going to give you. We want to start from one of the institutions, Jersey Zoo, but it gives you one example that is how you use your thermal cameras in a regular basis. You're thinking, well, that's quite cool. You do it once, and afterward, you needed the camera forever. In fact, what you start thinking is when you put in your basking lamps, these new lamps, they produce new heat, and you need to start thinking about if they cover the whole body of the animal, how long does it take? Does it cover the entire individual? You see a little bit cooler, the temperature with a gradient. That means the animal, the leg is not heating off. The same when you have in large reptiles like varanids, in that case Komodo dragons, you want it to have the whole body, because otherwise the poor animal is going to be heated in one little spot. It's not heating, and the animal is going to continue being under the spot for the long time. You may remember many cases where you see tortoises with burnt carapace, and they have a fantastic spot, but it's not covering the body. So the body is telling to the brain, stay on the heat, and this is burning itself because it's not covering. So it's very important to have that thermal cameras to see when you set up your design of your tank, it's getting the whole gradient. And this is something on a regular basis. And you check it as well on the seasons. You want to cycle your animals, you need to change as well the parameters of the environment. How are you going to do it? Thermometer by thermometer? You can take a whole spectrum, the whole picture, and understanding how your environment, your enclosures, your exhibits are working or not. That will be the case when you're working these days. And that is something that we're doing now more. For example, when we ask requirements in Paignton, they got a brand new Komodo that are going to exhibit. And the first question is like, are you doing all right? I want to say, well, let me just check it. Get the whole picture, and every single cross that you see there, that dot points that it can just prove it, that the animal has a huge range from 28 to 40 degrees. So the animal can have the choice. Thermoregulated, going and cooling, going and basket. So the ambient temperature is not regular. The animal has its choice, and it will behave in a natural way. The same you can see in perching, so the animal can have different options where it can go and choose the best area. This is something that it becomes much easier rather than long and extensive process of typing and describing the temperatures. You can just do the image, load it, and send it to your colleagues, and you get approved, and you see that it's a right enclosure. This is something that these days we do, for example, on the EP with the Komodo dragons. That will be with bats, so there will be another approach. We know how fragile bats are with the wings. One of the key sensitive things when you keep it free bats in particular is that when you know that there could be impacts, damage of the animals that are outdoors may have a frostbite. So it's important for the member staff that it goes and survey the animals. One key thing is rather than just hold the animal, again, not being intrusive, just simply getting closer. By scanning the wings, you will potentially identify if they have any injuries or is any damage on the wings. It's a very easy, soft way to don't disturb the colony, get it closer, and you can just have a better understanding how the animals are coping with the weather or the environment that you designed. Following bats, that will be the example of connecting your colonies with the animals in the wild. This is an endemic bat from Seychelles. It only lives in 2 islands, and Parque Natura Viva, they developed a project as a pilot study if it's a useful way to monitor the species in the wild. And what it did is using thermal cameras and spotting the animals in the different areas of the caves. With that information and the information that you collected from the cave, you identify the best areas where the bats like to roost. You do your calculations, you get your report. Automatically what you get is not only just the survey and census of the animals, but at the same time you identify what is the best area on the cave where the bats like to roost. So you can see really quickly what it could be a nice pilot study to save endangered species. Another project in Ménagerie Jardin des Plantes in Paris is monitoring the motions in real time. So we make it very simple in terms of stress response systems. We can divide it in 2 reactions, physiologicals or behaviorals. We're going to focus on the body temperature, how the body responds with this stress when you present it to the animal. And in the latest years, there's been a lot of studies developed about aversive and positive stimulus to the animals in a positive way and a negative way, and increasing or decreasing the temperature of the nose or the eyes. So the project, it was to potential thermography, using the thermography as a relevant tool to monitoring these emotions of the animals. And that was the first study. Small little group of animals, they provide the morning enrichment, and when they use the thermal camera, what you see there, that will be what they call the gun camera, and just pointing on the eye, and just if there's any response. The ferry was not response, so the temperature didn't increase during this enrichment, but they knew at least that species doesn't connect it, the increase of the temperature with enrichment. They went to the second study. In that case, what they did is feeding the animals in the morning, and they did a little bit extra, is teasing them, just pretending, but there's nothing there. So a bit of naughty, and see what they respond, the animals. The response is yes, they have an effect on the temperature. So this time, doing on the nose of the animals, have some significant differences on the temperature. So these species react, increasing the temperature, you have a positive stimulus. Obviously, you tease the animal, there is no response. Of course, they're not very impressed with you. One thing that it comes is not only the pros, but as well the cons of using this equipment. There are always limitations, of course, in technology. One thing happens is the temperature on the eye, if you get it too far away, what you see on the graphic, Far away you go with the meters, the temperature starts dropping. So the accuracy of the reading starts to drop. And this is something very important to consider. Another element to consider when you design your project and your reading will be that if you have objects in front of you, like glass, plants, trees, that is going to block the reading, and that won't provide you the right accurate information. Social studies, social behavior studies, and these are, again, in Parque Natura, they did a study working with chimpanzees, and they developed a method that it will be useful, thermal images, to study the behavior of the animals. And they wanted to identify if there's any particular part of the body that it would be better to express the changes during the agonistic or affiliative behaviors. So in the first study, when they identify after all the technical twitch, it was that the face of the animal, it was the better to use it for this study. They have a much more higher temperature, and it will be better than the rest of the body. On the second study, what they wanted to have it is with a control object in a controlled environment, because the temperature could change. These animals are outdoors, of course. The only challenge that you have it in this case, of course, is you have environmental parameters there. The wind, the sun, the air, and that can affect the response of the temperature, and also as well the fur, which we'll talk a little bit later. Having a thick fur, obviously is producing a layer of air, and it's not giving you the right temperature on the skin. It's giving you the temperature that reflects the fur. So it's something as well that it needed to be twitched, but it's a first approach under the right direction. Mulhouse worked with a species of turtle, with the European pond turtle, and that was in one of the projects that they did on the release. The question was if it's easy to measure the heat flow using thermal cameras, and if we can the external temperature be the proxy of the body temperature. Because if you wanted to go to the body temperature, you have to go inside. So you have to implant temperature data loggers, which is a quite intrusive technique. The alternative you have it as well is to stick it on the carapace. So what we did is plotted the temperatures external on the body, and you can see it really quickly in the graphic, is the temperature externally is slightly higher. So for obvious reasons I will see in a minute, the temperature data logger, it was completely radiated by the heat all the time. So the temperature, it was not relevant what it was internally. So the first approach, it was with the thermal image. They will give you much more reliable information, not intrusive. And with the plotting with the information that you have with the internal one, they identified that by 36 degrees Celsius, the animals start dumping on the water. So you can start thinking about ideas how you can measure the animal temperatures and basking behavior without using temperature data loggers. So it was a very practical project that you can just use it. Then we go now to the areas about the daily basis in our zoo institutions in terms of the veterinary team, the nurse team, or animal keepers that are working with this. And it's the elements that you don't see with your eyes. You move it from the visual to the infrared. And in that case, is an example, as for example, in Caracara. In this part, you identify very clearly that the temperature here is higher. You see it's on the right, on the top of the spectrum, compared with the other leg. So clearly you have a sign that is an inflammation. It's not going to tell you what it is. You cannot press any button in your camera and it will tell you what is the problem. But at least you know that it's a problem there. And you can just monitor if it's decreasing or increasing. But it gives you a slightly narrow target where you should react rather than capture the animal in stress in the first instant. One of the most common use has been on giraffes. That has been quite wide represented in many institutions about problems in legs. And you can just remember your vision and you look on your temperature. Higher in that case will be whiter. So you see it here in Warsaw. They identified that is a problem in that leg. And as well, they have a little bit on the tendons on the back. So really quickly you can do that. It's just by taking the images without restraining the animal, without stress, you can just have a quick, rapid assessment. You can have it there. In that case, it was an inflammation, for example, on the shoulder. So you can start seeing if there's any problem here. You can start taking your right decisions about how to manage the animal. Other example, in Yorkshire Wildlife Park, the same case. Comparing the two, when you have it higher temperatures, you identify we have a little problem there, an inflammation, which it could be multiple causes, of course. Here, there's quite useful as well is to have a comparison with other individuals. In that case, we have, let's say, a normal legs of the giraffe, and another one that you have clearly in Chester, some problems in the front legs. So you literally have to just compare them, and you can just evaluate what is the cause of. Other attraction it is when we develop a stress, it could increase the temperature of the sternum and the skin, which it will be an element to assess. So the approach that they got at the same institution was it will be, stress the public, the visitors, the activities, stressing the giraffe, and it can produce an increase of the temperature. So it was approached a different way of understanding a welfare with animals. The response was not. So in that case, it was not represented the stress on the animal by the presence of the visitors. In Alpen Zoo, for example, the same, working with elk, they identified punctual infection on the shoulder. Again, you always remember about keeping the color, because depending who takes the photo, they change the palette of colors. So what it looks like probably a cooler, probably will be a warmer. Always you have a reference when you take your photo that it will be the hottest spot, and that is the case. And you have a huge repertoire here. For example, in London Zoo, showing elements that, which is very useful in a thermal image, and I pointed one of the key examples here, a chimpanzee that it could have a bite, that it may don't have an open wound, but you probably perceive that something happens because his wound is reacting, the temperature is increasing, and you can just identify we have a problem. Something that probably with the eyes, in the visual spectrum, you won't pick it straight away. Or, for example, a reaction intramuscular injection in an elephant is increasing the temperature there, so we have a little problem, and we needed to react. Other issues, where it happens very often in birds, is the same case, with a turkey vulture in randers, where you can see the animal, clearly that leg has some problems, and it's something as well you can follow up. You can do a constant monitoring every day. You take the same photo in the same way to have a standardized method that you can just follow up without getting too intense. Then we have it as well with bears. In that case, the range of temperature in the other ones, it was wide. You see this one is red. So clearly we have problems here with the foot of that bear that it needed to be addressed. Important as well how the animal is thermoregulated. If it's getting probably in outdoors with too much heat, the animal probably is stressed. So it's important as well to take it into account, all these things. And again, following the animal for different seasons. Royal Zoological Society of Scotland, there was a very interesting approach in terms of studying the painted dogs. And one of the approaches, why using thermal cameras with these species? Being such a complex behavior on groups of animals, any approach on anesthetizing the animal, what it produces a lot of conflict in terms of the group and bringing back. So the last thing you want is interrupting the group, just leave it in peace. So using thermal images, what it can just is identify if there's any thinning fur on the coat, and it could be multiple reasons, but at least you know if it's on a problem before it's too late. So it could be irritation for a skin parasite, bacteria, allergic reactions, or even probably stress. So it's something that have to be aware about that. Could be a following in terms of the breeding, even that is probably not the best way to follow the breeding process, but it's something that it can help when you have the thermal cameras. A very good approach when you have social animals and you're the one that retreats from the group. Elephants, it was another element here. For obvious reasons, you don't have the possibility to anesthetize animals, so you try to put the hands off. In that case, you have a comparative study between two elephants or two legs in an animal in Chester, so a normal feed, and another one where you have an inflammation. And these, for example, here in artes, where you have a nail abscess, and you needed to just follow up again. By following these images in time, you can see the animal is recovering and is doing well. Other approaches with the range of tags, as you can see, is incredible. The different elements, the tooth root that you have access with an abscess here in a sea lion, or you have, for example, here a sinusitis on a zebra. So all these elements to try to avoid this stress. All the idea of non-intrusive techniques with the animals. And it could be something that you not even perceive, you're not picking up. But if you do it in a regular basis, it's elements like these wall-drop ibis, where you can find that the animal, it looks apparently to our visual eyes, nothing in particular. But when you put the infrared camera, it gets highlighted. Of course, this is probably picked as well in the behavior, because the animal is limping or it's not behaving well. But this complement of the tools is very important to get the things right in the time. We got in a different approach now, where we're talking about designing enclosures. Put it back your visual eyes. Can you see the chameleon? Yes, he's there. Means that not all of you. This is in Paris as well. And what he did in that case, the team, what he was working is to understand if the lamps that they put it there, which are here, in the morning they put in too close, too hot, or not. Do the chameleon basically is burning in no time, or it's not having enough heat. So in a very basic way, he took it a photo every 5 minutes. Get the lamps on and get it the first. Go back to your infrared eyes now again. Another 5 minutes. You see the temperature on the spot is telling you on the reader, so you can have that information on live when you're using your tool. 5 minutes more, you see the changes of color? And you get it after 30 minutes, the animal thermoregulate, as well as telling you that the animal is heated in the full body, not just one spot. As an example, for example, what we did with Komodo dragons. So it's the best example though, to check if the speed of the chameleon is hitting well or not, if the lamps are too close or not. Very basic things, but it makes absolutely vital for an ectotherm like this animal. Now to give you a video, this is a trial that we did it with the BBC, and on your left side, that you needed to find even more tune your infrared eyes. On the left side is the real time. On the right side is going to a time lapse. That means that in a few hours, it's going to speed really fast. At the beginning, the color of the animal is the same. Purple, blues is cold. Orange, yellows start to getting hot. It's not that the animal has palpitations and it's getting crazy. It's just a speed motion, okay? So it's time lapse, you see the animal. At the moment, probably your eyes doesn't perceive anything. It's gone, but it leaves the print. You see how it's been absorbing the heat even from the rock. Came back again. You see any difference of colors? Just a bit, huh? Not yet. It takes the time, and it's very important when we analyze this, is the head, body, tails, and legs are getting the same color at the same time. Otherwise, the setup that you put in for basking for your animal is not right. No, see a big difference here, huh? Slightly yellow, now it's getting yellow. So the animal starts heating, and now it gets really hot. So that's what we wanted. The animal gets to the level that all uniform in the body is heated by this temperature. It's something that you're not doing in time lapses, or you're taking it multiple times, you won't pick it up. And that's the difference now. Now we can see the difference between starting basking and after basking. So thermal cameras will help you with that. This is not new, for example. This is an example in Barcelona, and I think it was 2007, so more than 10 years ago. They have concerns that that baby gorilla may not be taking care of her mom well, and it probably is losing having a bit of hypothermia, and probably this animal is not doing well. We help a bit with the arrows to train our eyes. That's what appears the head and the legs of the animal. So the team decided to don't put the hands on the animal, just monitor how the temperature of the baby is doing, and not get the hands on and start hand rearing gorillas. I'm not an expert in gorillas, of course, but I can get it that once you start extracting food, it will be very complicated. So the important element of just monitoring the animal, and if he's doing all right, leave it there without getting in a complicated situation with managing the group. By following that, the animal was doing well and stay with the mom and happy end. Then we can monitor pregnancy. There's all of the elements here. So we can see the temperatures on the laterals and dorsals of the abdomen of this Java banteng. You can see the temperatures on females that is slightly higher. Again, remember always looking on the graphic, otherwise only simply see changes of color. It's higher than it will be in a male. So you just start thinking that that female probably is gravid. Then we go for all the different approaches, how they change these animals, how they adapted in a different environment. Helsinki sent us a really nice selection of images about how the animals, obviously Helsinki is quite high, so some of the animals may not be adapted to this latitude. And you see how the animals are minus 15 or 20, minus 20, the temperature is changing. Here you have batracian camels and vicuñas, obviously habituated. Mongolian horses, they're doing all right. Obviously European mink, you can see only just where the heat is coming out. The rest is well insulated. Then you see the changes between an Amur tiger and an Asian lion. That's slightly different. They live in different latitudes. So obviously that's just going to have an effect on losing the heat. And then you have to take decision about how you manage your animals. And always the same animal in different seasons. So you have it winter here versus summer. And you have the desert animals with different behaviors, obviously phoenix versus, for example, dwarf mongoose, where they're exposed in the heat non-stop. And then the master of that, they call the master of the winter survival, wolverine, get used to that temperatures, snow leopard, and look at the owl, just hardly just the eyes, you can see this losing the heat. The rest is good. So it's very important as well. In the other way, you can just compare in the low latitudes of animals that they come from the high latitudes are behaving, and you needed to react. So we just finalizing with this. We wrap up the presentation of that. We can see the pros and cons. And one of the things that is important as well is the limitations that you have with this tool. And what have the limitations is the weather conditions. You have solar radiations, depending what time of the day. You get rocks next to you, or they had reflections. The reading of this information from the animal is going to be modified. It's important as well if it's raining, so the rain as well is going to cool down for obvious reasons. So the information you collected has to be carefully recorded and mentioned that it's raining. If it's wind, it's the same way. You're going to have evaporation, and equally with the air humidity. So environmental parameters may tweak a bit your records. So this is certain limitations. It's not absolutely perfect. The distance, one element here is the distance. The farther you go, the wider the information gets collected. So you get it closer without disturbing, without affecting the behavior of the animal, the better it will be. The field view is better to have it at an angle of 90 degrees to low to 50. But, do it in that way, otherwise the information will be affected. We mentioned before with menagerie, they talk about the glass, so glass, fences, vegetation, trees, that is going to block. You could see, but the information that you collected, it won't be correct. Then you have the physical properties of the animal coat, and that is the thick layer of the fur. Thicker animals, they will have that layer of air that will buffer the temperature of the proper skin with the outside, because you will read it what is outside. So elephants, hippos, rhinos, it works really well. With animals with a thick fur, will be complicated. The physical activity, so recorded as well what the animal is doing, because obviously the animal is doing the exercise, is going to start increasing the heat, which it won't be reflected. Stressor elements, which could be multiple things. It's being treated in drugs, or it's having any other elements surrounding an environment. Any element, if your animal that you're monitoring is an animal that is under treatment, so you have bandage or any compress on the skin, that is going to affect the blood movement. So it's important to take into account that. And obviously any animal behavior, but it could be affected by the animal itself, or could be by the other species or the parameters. So this is something to consider when you design that. And just to finalize, if you're not convinced and you're not hot for it yet, that will be the summaries of the positive things of that. It's not an invasive technique. It's not an invasive tool. There is no light required, so anything that you needed to disturb to the animal is hands-off. Can be day and night. It's a wide range, so from the little tiny one adapter to the biggest one, so from 200 euros to as far as you can go. So there is a big range. Most of them, it goes in these examples from these 200 to probably 5,000 euros. This is the kind of material. Different color palette, I told you about that. You can easily load that information in your software. You can edit it. You can produce already templates with this information. High resolution. The distance can be quite close. Bidimensional lecture, so not like a point and laser. And then obviously you have all range of different gadgets. You can have voice recorded. You can have it, stream the video. You can have endless amount of things. And then you have that option, the tiny little one, which is a little pocket here, that you can put it and plug it in your Android or your iPhone, which is something very handy, and you can use it like your normal Uber reader or Lux meter. In case somebody wanted to practice and play with that, we brought one of each. So we have an iPhone and Android, so if someone is going to play around. I don't encourage you to do it tonight in case that you find surprises. But if you wanted to just practice during lunchtime or coffee break, you're more than welcome. And that's it. Thank you so much.
Thank you very much, and it's great to see so many EAZA collections already using thermal imaging for a wide range of behaviour and welfare issues. So I just have a very quick overview, I promise, it's not long till lunch. I just want to let you know a little bit of an update about what we're getting up to with the group at the moment. So EAZA Animal Welfare Group, well, we're really excited because we have a logo. We've kept it in sort of theme of the EAZA colours, and because it's really hard to find a picture that denotes animal welfare, we kind of just tried to cover all the taxa, so hopefully you guys like it. And thank you very much to Sosto Zoo, who designed it for us, and their graphics team did a wonderful job, and all the input of the committee as well. So we're very proud of it, and hopefully you'll see it lots in the next, the rest of the conference and coming years. You will have heard, if you've been to the tag liaisons, and thank you very much to many of the tags who have mentioned this, but our aim is for the group that we'll actually have a liaison with each of the taxon advisory groups where we can have really good communication and we can hopefully work together trying to pinpoint key research areas for welfare and hopefully incorporate more welfare into best practice guidelines. So far, we've had official nods from the following tags, but if anyone else is interested, please come and see myself or Sally from the EAZA office and let us know, because we'd love to work with you guys in the future. We're currently working on developing a welfare assessment library. So part of our core group currently have 15 animal welfare assessments from a range of zoos internationally, which have all been worked with and sort of trialled within those collections. And we also have a range of scientific literature that we've been using to support the use of animal welfare assessments in zoos and aquariums. And the aim is that we're currently developing a framework tool for EAZA collections to use that will help you decide on the appropriate animal welfare assessment that you can then use in your collection if you would like to, if you don't currently already do so. And that will be out hopefully in the next few months. And the most exciting thing that I am officially allowed to announce now is that we are running an animal welfare forum in early 2020, which seems a long way away, but please remember to put it in your budgets. And it's along the lines of the Conservation Forum, so we'll be bringing together practitioners, academics, people from the field, talking about animal welfare in zoos and aquariums. And I'm more excited to announce that I officially can tell you where it's going to be. And it's going to be held at Appenhall, so thank you very much for everyone who bid, but we're very excited to be going to Appenhall. So we'll be telling you a bit more about dates and a bit more information soon, so please look out for that, and we hope that many of you can come along. And if you'd like to find out more, we have a very active Facebook group, EAZA Animal Welfare, so please check up on that. It gives you information about the academy courses, key papers that are coming out, and any other relevant information that we think you might like. And we do have a poster all about the group, which also lists all our members if you want to find out who we all are. It's poster number 38, so rush over there quickly because I think they'll all be coming down quite soon. And before you go and get your lovely hot cup of coffee or maybe even a really hot lunch, I'd just like to ask you all to join me in a round of applause, thanking all of our keynote speakers for our session this morning. So thank you very much. Time for lunch. And if you'd like to speak to any of us, we'll up here for a while. Thank you.